Thanks, everyone. Sorry for the delay. We were all just trying to compile some code. Took 3 developers to get it finished off, and also forgive. Oh, I'm presenting the presenter view. Interesting. Oh, we don't really need those notes. Okay. Yeah, let's just go for it. So yeah, forgive me for the Zoolander pun, but I wanted to try to make a new database client that uses some of the new Scala 3 features and sort of combines a few of the different approaches we have for database clients on the JVM. I'm a Scala engineer at Axoni, which is a financial tech startup. We're working on the financial infrastructure for equity markets. And I first experienced Scala at Iowa State University, which is a sister school to EPFL. So we had some Scala programming courses, and that's where sort of learned like what a cool language it was and wanted to get involved in the community. I've done a few open source explorations. I've implemented generic coroutines on Project Loom, implemented UTF-8 validation using Java's incubating vector technology, and overall I just enjoy hacking new software, new tools, and experimenting with things. So we live in Washington State, and most of my jobs in programming have revolved around SQL. So it's something I've spent a lot of time thinking about and experiencing pain with. So the key questions and goals of this talk are to understand what type of SQL queries are we writing, what types of database clients are popular on the JVM, why are they popular, what makes the new client Magnum unique and differentiates it from the other ones, and what is the performance story and how the macros work if we have time. Another key question is, where's the AI in this presentation? It's sorely lacking, but unfortunately, I've been reading some Noam Chomsky over the last year, so I've invested too much time into his reading to get into it. If you don't know Noam Chomsky, he's very anti-AI. He created the Chomsky hierarchy, which is very influential in programming language as well. So yeah, I've kind of invested too much at this point. And interestingly, he was a fierce critic of Jane Goodall in the 60s, and he was able to sort of, fight against the hippies. And if he was able to defeat the hippies with Jane Goodall, I think AI has its days numbered. So anyway, once again, I wanted to ask the question, why yet another database client for the JVM when we have such a broad variety of flavors to choose from for Scala? And I figured, well, it worked for Circe, right? Just put yet another in the title and just throw everything together. So sort of analyzing why we need it, we should look at what type of SQL statements we write and sort of understand the use cases. The most common queries that we write as developers are simple CRUD operations. Find by ID, exists, insert, delete, update. These are the things we write the most of, but they're not particularly complicated. They should be generated at compile time, right, for us. We also write simple statements with a few joins. These are easy to write in SQL, and typically they're also very simple to implement. You write fewer of them, but they're very common. Less common are complicated SQL queries. These are ones with many joins and database-specific operations. So these queries we write very few of, but they take the most time and they're the hardest to do. And finally, there's dynamic queries. Think of, for example, if you're writing a search page where you're able to filter by some columns, sort by, or search by a partial first name, and then add pagination. So these ones are important to get right as well. We typically have 3 sort of branches of database clients on the JVM. We have object-oriented repositories, sort of around the Spring data umbrella. We have functional DSLs. Examples include JOOQ, Slick, and Quill. And these sort of emulate, they provide a DSL on top of SQL where you're able to write queries using a collection-like interface. We also have simple SQL string interpolators like Anorm, doobie, skunk, and plain JDBC. These are excellent as well and give you a more native feel closer to the SQL experience. So, object-oriented repositories. Let's walk through these 4 types of common queries we have and analyze how they do at solving the problems. For simple CRUD operations, they're great. Spring Data generates the queries at runtime, which is a bit ugly with reflection, but it works very well. Simple statements with a few joins, Spring has JPQL, which is sort of like a functional DSL. It's just implemented as its own language. Complicated SQL, you have to go out to a native query. And dynamic queries are solved by Java Enterprise specifications, which I don't know if anyone has used, but they're a great idea, but very unpleasant and slow. Functional DSLs are a very radically different solution to these problems. They typically don't have any handling for the simple CRUD queries, so you end up writing a lot of boilerplate. Simple statements with few joins are very good and generate great queries, but complex SQL queries with many joins are difficult to do, although most of these DSL libraries offer a string interpolator. So a big difficulty I have with functional DSLs, we use them at work a lot. You write a somewhat complicated SQL query, or you're trying to maintain one and understand why it's running wrong. Well, now you have to not only understand what the SQL is being generated, but also how to get the correct SQL out of your DSL. So there's sort of 2 layers of indirection. And for me, the best way to develop and maintain SQL is to be able to easily copy queries to a SQL editor like IntelliJ Data, Databricks, Datagrip, pgadmin, dbbeaver is great too. So that's a big challenge I have with functional DSLs, but for dynamic queries, they really shine, right? If you're building sort of a search engine or multiple pages, it's really easy to compose these queries because SQL itself is not composable at all. And finally, the SQL string interpolators. So they don't typically have any support for CRUD operations. For simple and complex SQL, they're great. But for dynamic queries, it's extremely difficult because SQL, the language, does not compose. And here are just some of the tools that make life developing SQL much easier. So what makes Magnum unique is that it combines aspects of all 3 types. It supports any database with a JDBC driver, including Postgres, MySQL, Oracle, ClickHouse, etc. It has a purely functional API. The common queries are generated at compile time. And it has a simple API with minimal abstraction because really writing SQL is hard enough, right? And now I'm going to walk through some of the features and give you a brief overview of how the library works. So starts out with a context function called connect, which creates a database connection. And within the scope of this connect, it provides an implicit database connection. And that is used by this run method. So you use connect to create a database connection. This is the SQL interpolator. You can create a query of the type that you want to read it as, and then you run it. Transact is very similar. It creates a database transaction. If there is an exception thrown, the transaction is rolled back, as you would expect. And in this case, we are creating an update instead of a query. You can have typesafe transaction and connection management by using implicits. That's a really good use case for implicits. And it's something you really miss when writing Java with Spring Data, right? Because typically transactions in Spring are using annotations. And it's very easy to mess the annotations up. For instance, if you call an async annotated method somewhere down the call stack of a transactional method, you will lose data from your database. I've seen this happen a lot of times. So having the type safety to know that you require a transaction, so add a using clause for your database transaction is perfect, and a super great feature that many of the Scala libraries have. So in this case, we're this get users method is using a dbcon or database connection, and run update and get users uses a db transaction, and of course dbtx extends db connection. So you can call get users from the scope of run update and get users. You can customize the transactions generated by the JDBC connection. This is actually a pretty challenging thing. Jumping ahead here. It's a pretty challenging thing to do in quite a few libraries, surprisingly. But if you want to change the transaction isolation, like set it to serializable or repeatable read, that's an important thing to be able to do. So a few more API notes. We have a SQL interpolator, a frag class, query class, and update. So when you type SQL and you feed it a SQL string, this generates an instance of frag, which represents a SQL fragment of any expression. Of course, it uses prepared queries, so there's no problem about SQL injection. And you can then get a query. It's really jumping around. You can then get a query by calling the query method and passing the type that you desire it to be. Update is similar. You just call update. And finally, you use the run command for both in order to execute the queries. So batch updates are also supported. You feed the batch update method your iterable of items, and then it uses the JDBC batch updating functionality. Now, here's a really interesting part, and something I have not seen so far in any Scala libraries, and that is the repositories. So starting off, we have an immutable repository. It has only methods which do not modify the table, such as count, exists by ID, find all by ID. And here's an example. So starting out, we have a case class user. This is mapping to our database table. And we see we have columns ID, first name, last name created. And importantly, we have the @table annotation, which defines the database type that this table is implemented for, and an optional parameter that defines the name mapping. So typically in Postgres, we use snake case. So this parameter automatically maps the Scala field names to snake case. The ID annotation is optional, and you only need it if you have an ID. Otherwise, it uses the first parameter. We also derive this DBCodec, which is used for reading and writing to JDBC result sets and prepared statements. We create an instance. We create an instance with this immutable repo constructor, and we pass it the class, the entity type, and the ID. And from there, it's very trivial. We can call any method we want, like count, find by ID, etc. Everything's generated at compile time. And following the Spring data, it seems to be a good practice to encapsulate your queries within types, such as like a user repo. So you can easily extend immutable repo and then define all your similar queries in the same class, which really helps with maintenance. Next, we have the full repository, which extends immutable repo, and it additionally derives all the other CRUD operations you'd be interested in, such as delete, truncate, insert returning, update. And here's another example of a repo. Notice that it takes 3 type parameters this time. And here we have a transaction where we use the repo to delete an ID and then return the count. Once again, it's good to extend the repository for encapsulation. We also support database-generated columns, which is sort of a unique thing among Scala SQL libraries in a type-safe way. So oftentimes we have database-generated columns like ID created by, and the derivation supports this in a very transparent way that has great editor support in all editors. So here's the same user table definition. And here is the user creator case class, which derives DBCodec as well. And here, when we instantiate the repo, the first parameter is the entity creator. The second parameter is the entity, and the third parameter is the ID. So the macro checks at compile time as well to ensure that the entity creator is a strict subset of the entity. So if any of the field names of user creator are not found in user, or they have different types, it will fail to compile. Here's an example where we use insert returning. So this, you pass it the entity creator and it returns the entity. So that way you can get the IDs and other generated fields back from the query. And finally, we have specifications, which are a reimagining of the Java Enterprise Edition specification. You need to do 3 steps before you can use specifications. You need to perform, if you need to perform the joins to get data, you first want to create a database view that has all of the columns that you're interested in. Then you create an entity class deriving DBCodec. This is a typo. And then finally, you use the spec class to create a specification. So here's an example. We have a few things we're interested in. And here's the instantiation. This is a specification of the user class where the first name is like the search that we're having in our search results table. I is just a case insensitive like. We have another where clause where the created date has to be greater than or equal to the search date. And the specifications support seek-based pagination, as well as offset-based pagination. Seek-based pagination is a lot faster. So you give it a column and you give it a position. And whenever the user requests the next page, they provide the ID where the ID of the last page. And from there, you can generate your next results much quicker than using offset. And this is supported using the find all method on user repositories. We also have full support for Scala 3 enums. So you can derive a Scala 3 enum of any type and use it in your table definitions. And by default, it serializes enums to strings, but that is customizable. DBCodec is the type class that we use for reading and writing. It has some low-level methods like reading from result sets, writing to prepared statements. And there's given DBCodecs for many types, tuples, integers, options, etc. So looking at the 4 sort of common queries we have. So this new library Magnum, with regards to CRUD operations, they're derived at compile time. For simple statements with few joins, excellent. Complex SQL with many joins and database-specific operators, fully supported in the SQL Interpolator, and it's easy to copy back and forth between SQL editors. And for finally, dynamic queries, we have built-in support with specifications. Yeah, would love for you all to give it a try. We just released version 1.0, and it is available on Maven Central. Thank you, everyone.